This is the Spring 2018 Principles of Programming Languages Mini Project presented by Michael Wegner and Ariel Riggin. The .NET framework was developed by Microsoft and allows for multiple languages to be used in the development of programs. The framework enables programs to execute in a software environment. This allowed Windows to become the object-oriented view that it is today. Encapsulated by the framework are multiple APIs and hardware drivers. Programs built upon the .NET framework can utilize the vast libraries to communicate with the hardware and other software programs. In the 1990s, Windows was built upon the DOS operating system. The issue with DOS in the 1990s was that Windows apps required a Windows runtime environment. If a user wanted to create a Microsoft Word document, they would install Windows through DOS and then create the document. In the early 2000s, Windows created the .NET framework. .NET ran on top of Windows and provided APIs that developers would have to create on their own in the past. .NET allowed people to utilize many tools in the development process. Many of these tools are very similar to topics discussed in the Spring 2018 Principles of Programming course.
The documentation on .NET, there are three main sections of the framework's architecture: language, library, and common language runtime. Language is not referring to common programming languages like Java, Python, C++, etc. Language, in this case, refers to WinForms, which indicates a form-based applications, ASP.NET for web-based applications, and ADO.NET, which is used for applications that have interactions with databases like SQL. The different application types all then can call from .NET's library of methods and functions, which makes up the second main section of .NET. Lastly, there's the Common Language Runtime, which is really the powerhouse of the framework. The CLR runs on the Common Language Infrastructure, also known as CLI for .NET. The CLI is the platform on which all applications are executed. It deals with exception handling, garbage collection, and is where different programming languages are incorporated into the framework. Why might people prefer to use .NET? Well, the .NET framework provides excellent back support for older versions, which ensures that developers don't have to continuously update older versions of applications to stay running with .NET's framework. .NET is also convenient in that it ensures that applications work on any Windows platform. When developing for different Windows machines, this feature can be useful. Also, .NET helps to manage memory. This takes place in the CLI, which we referred to earlier, where stored memory that will not be used again is removed through garbage collection. Another powerful feature of the framework is its built-in security. .NET allows for developers to pick and choose which security features are best for their applications, which makes things easier for the developer and safer for the user. Lastly, .NET has a set of tools to assist users with installation. .NET's framework has a common type system, also known as CTS. According to the documentation on .NET's common type system, types in .NET fall into two categories: value types and reference types. Both of these types we've seen in parameter passing for labs 4 and 5. A value type is essentially call by value, where the object is represented by its value. The other reference types are equivalent to call by reference, where something's value is represented by a reference to the actual value, like a pointer. Diving a little bit deeper into types, we can see that all types are broken down into 5 categories for .NET: classes, structures, enumerations, interfaces, and delegates. We've seen most of these before. Enumerations is a little different. It is a set of basic types that are defined by a file called system.enum. This holds basic types like bit fields, for example.
A defining characteristic of functional programming languages is the elevation of functions to first-class status. You should be able to do with a function whatever you can do with values of the other built-in types, and be able to do so with a comparable degree of effort. A user can ask themselves the following questions to determine if a function is first class in the framework they are using. Can you bind functions to identifiers? That is, can you give them names? Can you store functions in data structures, such as in a list? Can you pass a function as an argument in a function call? Can you return a function from a function call? If a function can do all of this, then it is first class. In the .NET framework, a function can be used in the following ways. Here's an example of a function being bound to an identifier, meaning it is given a name. The following example defines a function named squareIt by binding the identifier squareIt to the lambda expression seen below. Function squareIt has one parameter in, and it returns the square of that parameter. Here's an example of the squareIt function from the previous slide and a new function, doubleIt, being stored in a list called funList. This is an example of two functions being stored in a list in the .NET framework. Here's an example of a function being passed as an argument in a function call. Being able to send a function as an argument to another function is common in functional programming languages. A map operation, for example, is a higher order function that captures the computation shared by functions that step through a list, do something to each element, and then return a list of the results. The difficult step in the computation is the recursive process that steps through the list and builds a list of the results to return. This step is completed with the mapping function. The mapping function allows for the developer to create one function that they want to apply to each list element. This function is sent as an argument in the mapping function. This same process was utilized in Lab 5 as seen below. And finally, here's an example of a function being returned from a function call. As you can see below, the function returning another function allows for this function to be recursive.
One of the upsides to using .NET is that it has an abundance of built-in higher-order functions. As we know from this semester, higher-order functions can make our lives a lot easier. We really started focusing on them in Lab 4 with functions like fold left, fold right, and map first. Could you imagine passing multiple parameters without the fold functions? Then in Lab 5 we used rename, and in Lab 6 the test function was a higher-order function. Test was a huge part of that lab that made testing regular expressions against strings more succinct and cleaner. So what do these things have in common? What is a higher-order function? Well, higher-order functions are those that take in functions as parameters. Simple enough. Here we can see some of the definitions and implementations of these functions. These first four are from our labs and were examples on the previous screen. This one, find all, is a higher-order function from the .NET framework. So looking at these, we can see that in map first, there is the function being passed in as a parameter where some type A is being evaluated to some option of A. Similarly, in fold left, we can look through these and see our function parameter here, where as parameters we are passing in some type A and some integer to evaluate to some type A. Again, rename. Here we have our environment, our expression, all of that familiar jargon. And then here we see fresh, the function that we're passing in, and we're taking in a string and continuing to make it into a do with W and string. Test, which we used for regular expressions, has the success continuation function as the parameter, which was a large part of how we made test work. It also worked well for our examples with trees. Now moving down to find all, this is an array that takes some function and looks at each element in the array with the function acting on it to find a certain match. Once that match is found, it is returned, similar to something we've done in labs. Here we can see that our parameter is this variable Yuri, and that's being passed over here, and it's being compared to null.
A callback function within the .NET framework is code within a managed application that helps an unmanaged DLL function complete a task. A DLL is a dynamic link library, which most of the functionality of the operating system depends on. Calls to a callback function pass indirectly from a managed application through a DLL function and back to the managed implementation. Some of the many DLL functions called with platform invoke require a callback function in managed code to run properly. PPL used callbacks as executable code that were passed as an argument to other code, which is expected to call back or execute the argument at a given time.